It's with great pleasure and honor that I present the Scientist of the 19th Century Award to Niels Henrik David Bohr, also known as Niels Bohr. He was a Danish physicist born October 7, 1885 in Copenhagen, Denmark, and died November 18, 1962 in Copenhagen, Denmark. His father, Christian Bohr, was a professor of physiology and was nominated twice for the Nobel Prize. His mother, Ellen, was the daughter of a well-known Jewish banker. Bohr was the second of 3 children born into an upper-middle-class family. He had an older sister named Jenny and a younger brother named Harold. Harold became a brilliant mathematician as well as an international footballer. Bohr was homeschooled until the age of 7. He attended Gamel Home Latin School along with his brother Harold. Here, he learned strict discipline and hard work. He did well in school, coming in 3rd or 4th in his class, but surprisingly, he excelled in physical education. He was an excellent football player, though not as good as his brother Harold. Bohr and his brother were very close. Some even say they were inseparable. Bohr took on after his father and enrolled into the University of Copenhagen at age 17 in 1903 to study mathematics, chemistry, and astronomy, but majored in physics under the instructions of Professor Christian Christiansen. In 1905, the Royal Danish Academy of Sciences announced an award for the best research paper on the properties of surface tension. Though he was still an undergraduate, he was ambitious. He took on the experimental and theoretical investigation of surface tension in his father's laboratory. Niels spent countless hours working on his experiments and eventually finished his paper late 1906 and won the gold medal. 2 years later, his work was published in the Transactions of Royal Society. In 1909, he received his master's degree in physics, and in 1911, his doctor's degree. In 1911, Niels Bohr was chosen among a few to follow the experimental work going on in the Cavendish laboratory under Sir J.J. Thomson's guidance. He had intended to stay his entire period at Cambridge but did not get on well with Thomson. Niels also conducted research on cathode rays that did not appeal to Thomson. The following year, Niels transferred to the Manchester laboratory and worked with the guidance of Ernest Rutherford to complete his postdoctoral research on the atomic structures. Niels Bohr was the first to theorize electrons orbit at the atom's center instead of being mixed in with protons and neutrons. He proposed a model of the atom where electrons were only able to occupy certain orbits around the nucleus. His atomic model was the first to use quantum theory, in that the electrons were limited to discrete orbits around the nucleus. In these discrete orbits, electrons do not radiate energy. When electrons jump up, they require energy, and when they fall down, they lose energy and release photons. Bohr used his model to explain the spectral lines of hydrogen. This model had limitations as you moved further away from hydrogen. For his work, he received the Nobel Prize in 1922. Around the time he was awarded the Nobel Prize, his colleagues George Hevesy and Dirk Koster worked at his institute to establish experimentally the undiscovered atomic element 72 would behave as predicted by Bohr's theory. They succeeded in 1928, proving Bohr's theory. The element was named hafnium, Latin for Copenhagen. 1912, Niels married Margaret Norland, the sister of the mathematician Niels Erik Norland. Together they had 6 sons, but unfortunately 2 passed away. The 4th son, Ag Bohr, shared a third of the Nobel Prize for Physics. In 1913, Niels published a paper on the atomic structure which laid the foundation for the old quantum theory. Bohr proposed a theory for the hydrogen atom based on the quantum theory that energy is transferred only in certain well-defined quantities. Electrons should move around the nucleus but only in the prescribed orbits. When jumping from one orbit to another with low energy, a light quantum is emitted. Bohr's theory could explain why atoms emitted light in fixed wavelengths. In 1913 to 1914, Bohr held a lectureship in physics at Copenhagen University, and in 1914 to 1916, a similar appointment at the Victoria University in Manchester. In 1916, he was appointed professor of theoretical physics at Copenhagen University, and since 1920 until his death in 1962, he was the head of the Institute for Theoretical Physics. Bohr also collaborated with Werner Heisenberg and other scientists on the new quantum mechanics principle in connection with his concept of complementarity, which was established in 1928. The concept of complementarity stated that the physical properties on an atomic level are viewed differently depending on experimental parameters. His concept explained why light can behave as a particle and a wave. Objects have different properties, but these properties cannot always be seen at the same time. 1933, Adolf Hitler came to power in Germany. Many of Bohr's colleagues were Jewish and lost their jobs. Bohr provided shelter to the German Jewish physicists at his institute in Copenhagen. When Denmark became occupied by the Nazi force, Bohr and his family moved to Sweden and eventually fled to the US. In the US, he worked on the Manhattan Project and eventually built the first nuclear bomb. Bohr was peaceful, so he became concerned about how the nuclear weapons are being used. In a public letter to the United Nations in 1950, he argued for rational, peaceful atomic terms. In quote, he said, "Humanity will be confronted with dangers of unprecedented character unless in due time measures can be taken to forestall a disastrous competition in such formidable armaments and to establish an international control of the manufacture and use of powerful materials." Bohr was a writer with over 100 publications to his name. In 1962, when Bohr died of sudden heart failure at his home in Copenhagen, Denmark, his son Age Bohr with two others shared the Nobel Prize in 1975 in physics for his research on motion in atomic nuclei.